Levers. Levers are the simplest kind of machines. They work on the principle of moments. It rotates or moves from a fixed point called fulcrum. It turns about a point called fulcrum. It is just like the pivoted end of a body. And this fixed point called the fulcrum does not move. So they are the simplest kind of machines. They turn about a point called fulcrum, and the point fulcrum does not move. Then, based on the position of effort, fulcrum and the load, levers are classified into class 1 lever, class 2 lever and class 3 lever. In class 1 lever, fulcrum comes in the middle. In the class 2 lever, load comes in the middle. And in the case of class 3 lever, effort comes in the middle. For easier calculation and for easier recollection, we remember the word FLE. That is, F stands for F in the middle for class 1, L in the middle for class 2 and E in the middle for class 3 levers. Let us move on class 1 lever. In the case of class 1 lever, fulcrum comes in the middle, effort and load comes on either side. Look at the direction of effort and load. Both are acting downward. Fulcrum is the fixed point in the middle. Here, all distances are measured from the fulcrum in the case of levers. So, from the fulcrum to the load, it is called the load arm. From fulcrum, the distance between fulcrum and the effort is called the effort arm. In the same case, class 1 lever, in this case, fulcrum is near to the load. Here, effort arm is greater than load arm. Load arm and effort arm is measured in the same way as earlier. In the third case, fulcrum is very near to the effort. In this case, load arm is very much greater than effort arm. In this case also, load and effort in the downward direction. So, class 1 lever. In the first case, if the effort arm is equal to load arm, from the value of mechanical advantage, we can find out the function of the lever. In this case, second case, effort arm is greater than load arm. And in the third case, load arm is greater than effort arm. Fulcrum near to the effort end. Let us calculate the value of mechanical advantage from the equation for levers. Mechanical advantage is equal to effort arm by load arm. So, in the case of class 1 lever, there are 3 special cases. In the first case, effort arm is equal to load arm. So, denominator and numerator will be equal in magnitude. If the load arm is equal to the effort arm, the value of mechanical advantage is equal to 1. If the mechanical advantage is equal to 1, what will be the function of a simple machine? If it is equal to 1, it is a machine which is used to change the direction of the effort in a convenient direction. In the second case, mechanical advantage is greater than 1. So, the function will be as force multiplier. In the third case, mechanical advantage is less than 1. So, the function will be as speed multiplier. So, mechanical advantage, if it is greater than 1, force multiplier. If it is equal to 1, change in the direction of the effort to a convenient direction. If it is less than 1, it acts as a speed multiplier in the case of class 1 lever. So class 1 lever has 3 functions. Next, moving to class 2 lever. In this case, fulcrum on one end, it is a fixed point. Then load comes in the middle. It is acting downward, as load is a kind of force or a weight. It acts in the downward direction, and at the extreme end opposite to the fulcrum is the effort. The distance between fulcrum and the effort is the effort arm. The distance between fulcrum and the load is the load arm. In this case, effort arm is greater than the load arm. So let us calculate the value of mechanical advantage. What is the equation for mechanical advantage? Mechanical advantage is equal to effort arm by load arm. So in this case, mechanical advantage is greater than 1, as the effort in the numerator is greater than the load arm in the denominator. So this class of lever acts as a force multiplier. So class 2 lever has only one function. As the mechanical advantage is greater than 1, it acts as a force multiplier. So class 1 lever, the function is explained. In the case of class 3 lever, here fulcrum comes at one end, as I said before, but effort comes in the middle in the upward direction. See, you should be very careful in the direction of effort and load while you draw this diagram. The load always acts on the downward direction, as it is a kind of force or weight. So the arrow will be always in the downward direction in the case of load, but in the case of effort it will be different. So in this case, load arm is greater than effort arm from the figure. So let us calculate the mechanical advantage. The effort arm is smaller than load arm. So the mechanical advantage value is less than 1. If the mechanical advantage is less than 1, then what is the function of that particular machine or lever? If it is less than 1, it acts as a speed multiplier or gain in speed. So class 3 lever, its function is only it is used as a speed multiplier. So class 1 lever has 3 functions: force multiplier, change in the direction, and speed multiplier. Class 2 lever has only one function. As the mechanical advantage is greater than 1, it acts as a force multiplier. In this case, let us calculate the velocity ratio also. Then mechanical advantage is less than 1 for class 3 lever, it acts as a speed multiplier. Velocity ratio is also less than 1, so it acts as a speed multiplier. Then principle of levers, this principle is based on the principle of moments. Load into load arm is equal to effort into effort arm. From the above 3 cases, let us calculate the